Alright, so today we're going to talk about kites and trapezoids. So the first thing that I want you to do is get out your quadrilateral family handout, and let's list all of the things that we know about kites. Okay? So we know that it's a quadrilateral and two pairs of adjacent sides are congruent. Well, what exactly does that mean? Well, if this is my kite, it means that these are adjacent sides, they're congruent, and this pair of adjacent sides are congruent. Okay? We also know that the diagonals are perpendicular. So, if I were to draw the diagonals in here, since they're perpendicular, I know that they make a right angle. Okay? The third thing that we can say is that one diagonal forms two isosceles triangles. One diagonal forms two isosceles triangles. So I'm going to color those in green. So this is an isosceles triangle because these two pieces are congruent. And this is also an isosceles triangle. Number 4 says that the other diagonal forms two congruent triangles. Meaning that this triangle right here is congruent to this triangle right here. Okay? I know that's kind of messy, but hopefully it'll make a little bit more sense as we go through. And actually, if you want, we can just redraw it with all the things that we know. Okay? So I know that my diagonals are perpendicular. This means that this is a right angle. I know that this is an isosceles triangle. And I know that this is an isosceles triangle. I know that this triangle right here is congruent to this triangle right here. And then I know that it has two pairs of adjacent sides. Okay? Alright, so what do we know about trapezoids? Well, first of all, these are all quadrilaterals. I didn't say that, but you know that. A trapezoid has one pair of parallel sides. And really this is only one pair, right? It has only one pair of parallel sides. The second thing that we know is the median is parallel to the bases, and it's half the sum of the bases. So let's talk about that really fast. I'm going to draw a picture of a trapezoid. Okay, so remember that a median is when we take the midpoint of two segments and we connect those midpoints. So I know that this piece is parallel to this piece. That's the given, right? That's the definition of a trapezoid. Well, it says that the median is also parallel to the bases. But the other thing that it says is that the median is half of the sum of the bases. So if I call this little guy M, 6 plus 10 equals 16, and half of that is 8. So the median is 8 units. Okay? Let's see, what else do we know? That's it for a trapezoid, but what about an isosceles trapezoid? What if we have an isosceles trapezoid? Okay, so still the same features as a trapezoid, but additionally, because it's isosceles, we know that the non-parallel sides, known as legs, are congruent. We that the base angles are congruent. We know that the opposite angles are supplementary. And the last thing is that the diagonals are congruent. Okay, so that's the stuff that we know about kites and trapezoids. So now let's get through some of our notes. All right, so trapezoid and kite. Theorem 615 says that the base angles are congruent. The base angles of an isosceles trapezoid are congruent. So really what that means is if I were to label this trapezoid A, B, C, D, that means that angle C is congruent to angle D, and it means that angle B is congruent to angle A. Okay? So that's what theorem 615 says. So knowing that, I have trapezoid X, Y, Z, W, and it's an isosceles trapezoid. The measure of angle X is 156. Well, I just learned from theorem 615 that if angle X is 156, angle Y is also 156. I don't know what the measure of angle W or angle Z are, but I know that they're the same, so I'm going to call them both X. Now, I know since this is a quadrilateral, the sum of the interior angles is 316, so I can write an equation. 156 plus 156 plus 2x equals 360. 2x equals, let's see, 156 plus 156 is 312. If I take 360 minus 312, I have 48. So 2x equals 48. When I divide both sides by 2, I find out that x equals 24. So that means that the measure of angle W equals the measure of angle Z equals 24 degrees. Okay? All right. Theorem 616 says that the diagonals of an isosceles trapezoid are congruent. That means that AC, segment AC, is congruent to segment BD. And because they're congruent, I could also say that AC, the distance, equals BD. Okay? All right. Theorem 617 says that the diagonals of a kite are perpendicular. Well, we already know that. Hopefully you remember that from our quadrilateral family sheet. So because they're perpendicular, that means that the diagonals form right angles. Okay. The diagonals form right angles. So in example 2, I need to find the measure of angle 1, the measure of angle 2, and the measure of angle 3. Well, I have diagonal SU and diagonal TR, and I know that SU is perpendicular to TR. I just learned that in this theorem right here, 617. Okay, so that means that the measure of angle 2 is 90. All right. So if I know that the measure of angle 2 is 90, that also means that this right here is 90 because they make a straight line. So now if I wanted to find out the measure of angle 3, I can just take 90 minus 72, and I come up with 18. So the measure of angle 3 equals 18. But the other thing that we need to know is that these are, remember these make isosceles triangles, so if these sides are congruent, if this side is congruent to that side, then these angles are also congruent. So that means that the measure of angle 1 equals 72. All right? So thinking about all the things that we can say about a kite, because these two sides are congruent, I can also say that these two angles are congruent. And then, if I needed to, I could prove that dt is congruent to dt using the reflexive property, and then I could say something to prove that this little triangle is congruent to this little triangle, or that this big triangle right here is congruent to this right triangle. So really, the diagonals make two pairs of congruent right triangles. Two pairs of congruent right triangles. All right, let's look at, wow, is that it? Okay, that's it. So your homework is page 323, 3 through 24, multiples of 3, 27 through 31, and 39 through 42. Good luck.